Hi, and welcome to another video tutorial. This time we'll be discussing briefly how do we perform activation function, more specifically the softmax activation function in Python, and as well as discuss ko na lang ang loss. How is the quick overview on how we perform the loss calculation in Python as well, related to your neural networks. Okay, so in the previous video, you've already known how to perform the with some the activation simple activation function in the hidden layers. Okay, so now specifically, we will see how do we perform your softmax function, because in the previous activities that you had, you already have the knowledge to perform your step function, your relu function, and linear function kay y is equals to x. Malami siya. So most of the functions, activation functions, you can look up online to see how they are implemented in Python. But now, i-explain ko lang specifically sa softmax function, and how do we perform it, the constant, the Euler's constant, and as well as some of the techniques in order for you to easily calculate the values. Well, not easily to to handle certain problems now when it comes on dealing with floating numbers. Okay, so given here, is just a simple example of calculating the softmax activation function. So that softmax na siya. So if you remember, the softmax, in getting the softmax, that is 1 divided by 1 plus the e, Euler's constant, raised to the negative x. So the negative x are your output. Okay. So if you don't see, this is the equation I've used for the what call this, the Euler's, sorry, the equation for the softmax function. And remember, we use the Euler's constant here as a softmax function. So therefore, we need to get that specific value. Now you can put it as a constant, and then later on, if you have implemented, if you also have, imported the package math, you can get the exact value of the Euler's constant there. Okay, so here we are given an example, Let's say we have 3 hidden layers, or 3 output nodes in this case, to which has their weighted values, individually, so 4.8, 1.21, and then 2.385. No? Okay, so we need to perform the softmax function for each of these outputs. So overall, we will have 3 outputs that we need to handle or we need to display. Okay, so for that, you can use simple for loop iteration, for loop, in order to iterate in that for each object or for each outputs, I mean. And here, so it will store the values here in the exponential value. Okay, okay, so that is going to be the output of the softmax function. Okay, but in this case, so whatever output pa na siya, that is going to be floating numbers. So you will be considering a lot of decimal points. So in handwriting cases, that is going to be a big problem, as well as in computers, especially if you are managing optimization, in terms of memory management, and reducing the probabilities nga nga man siya, it will turn to zero, because it will handle too many zeros. Okay, so let us run this, no, for example, in order to see. Okay, so wait a minute. So I will be back once I've finished installing this example right there. Okay, so let us try to run this one. Okay, selecting the interpreter. Okay, so here we have executed. Okay, let's try to run this. Okay, so as you can see, this is just with the given constant. No, what if you want to consider all of the decimal points of the US constant? So that will take a lot of decimal places. Okay, so in that case, no, okay, we need to normalize in order to solve the problem with floating numbers. Okay, so in order for you to normalize that, no, uh, you can get the sum. So you will have your base values, no, the base values or your denominator. Then for each of that value right there, no, okay, so you can try to normalize that one. Okay, so normalize na siya. So for each of the values sa exponential, that's 3, no, you divide the value by the norm base. Okay, then after that, you can see that, well, no, it is too manageable na siya. No? And here, we are targeting AB to be that the sum of the normalized values is equal to 1. So that describes AB the sigmoid function, no, specifically used for classification. You can do this one, I think. Okay, so yes, no, so that's used for classification problems, no, especially again, C of max was stated to be commonly used for classification. Okay, so if you don't want to manually calculate, no, use yes to calculate the sigmoid values, you can also use the numpy. Okay, so here, no, very convenient pansin numpy because there are some functions for you to use, especially sa previous video, you have used the dot product, no, with the transpose, no, very easy. Okay, so in this case, ang obround lang dire is, well, we will get the exponential values, no, calculate exponential value by using the exponential function of your NP. Okay, so this one automatically uses the Euler's constant. As you can see right here. Okay, so let me just run this one first. Sorry. Then let's try to execute. Okay, so if you check, that is the same. Well, not really the same because mas shorter na siya. So maybe truncate ni numpy, no, or numpy by a set of decimal values. Okay, so after that, you perform your normalization again of values in order for you to reach the um, in order for you to reach the probabilities, no, for your classes. Okay, and as you can see, may gamay lang nga difference with the output, so not necessarily 1.0. No, so this is just 0.9999. So medyo nagnubo ang aton nga normalized values, no, it might be because of the truncation of the decimal points. However, that's passable man na siya because the difference there is 0.00000001 and so on. Okay. So that's it for activation functions. No, very easy to do lang. There are a lot of Python codes for that as well. Okay, now let's talk about loss. Now, again, this is just to show you how do we calculate loss, no, in Python, no, specifically used for neural networks, and well, sometimes used man siya in other machine learning techniques. So, in calculating the loss, no, you need to consider the two major components: your predicted output, no, the output given by your by your neural network, no, in this case by your activation function, and the ground truth, the target, the y. Okay. Okay. So here we have an example here. One example here, no, we have the outputs no calculated from the softmax nga ano, activation function. We have 0.7, 0.1, and then 0.2. Okay. And here is the ground truth, no. So mean to say, ang ground truth diri is the class, no, should be the correct class should be the class 0 mana siya if ever. So the rest of the class should be 0. Now, with this, no, with loss, calculating loss, you need to determine kung gaano man na siya kalayo, no. How far is the predicted output, no, from the target output. Okay. So in order to calculate the loss, okay, so that's just ano. Okay. Okay, so calculating the loss for each output na siya, no. So this is going to be negative. So if this is based on the function, or sorry, on the formula for calculating the categorical cross-entropy, no, commonly used for classification problems. Okay, so since here we have three classes, no, so we need to compute the loss for each output, for each class, I mean. Okay, so this is for the first class, no? This is for the second class, and this is for the third class. Of course, there are three possible classes, no? So we need to calculate the loss of each of these classes, no, in order to determine the overall performance of the neural network. So we are not only calculating the prediction of your model of a single class, no. So we need to get the overall, or the overall performance. Okay, so for that, no, if you remember to sa presentation, so that is just the log function of the softmax na multiplied by the target output. Okay, so we get, no, the log function of that multiplied by the target output, no. We do this for every class, and then we get the sum of all of the outputs. So with this, no, that is the loss of the softmax output, no, which is 0.356674, etc. Okay, so another thing for you to do, no, instead of manual calculating, no, or performing an iteration or loop man siya, you can just perform or get, no, get the function, no, performing just the math.log of the first nga output of, yes, the first nga class, I mean, since all of them, no, since the first class has the value of 1, while the others has the value of 2. So you're essentially just multiplying them by 0. So basically, yes, they're the same, no, but however, yes, yes. So I think that's it, no, for the loss, no. Okay, so for linear regression, I think you just perform, or for regression functions or regression problems, no, your binary or your binary classification, yes, as well. So there are specific formulas for that, and yes, you can find a lot of sources, no, or Python implementation for a specific problem. Okay, so I believe that's it, no, for this example. Thank you for watching, and see you on the next video.